Hello, geometry. Thanks for tuning in. Hope your day's going swell. Let's jump right into it. We've got a one-page set of notes today. You're welcome. We're talking density and specifically population density. So, what is density? Well, density of an object is the mass per unit volume. What does that mean? You might have dealt with density in like a chemistry class or something like that. If you've taken chemistry, you've heard the word tossed around. If I were to put it in casual terms, density is the amount of stuff inside of the thing. Density is the amount of stuff inside of a thing. What do I mean by that? Well, consider all the different balls that are in the world, right? You could have a bowling ball, you could have a styrofoam ball, you could have a basketball, you could have a baseball. They're all round and all relatively the same size, except for a baseball. And let's replace a baseball with a basketball. So you could have a large styrofoam ball, you could have a large bowling ball, and you could have a basketball, and they're all about the same size. But are they all the same density? The answer, no, right? What's inside of a styrofoam ball? More styrofoam. What's inside of a basketball? Air. What's inside of a bowling ball? Something. whatever a bowling ball is made out of, right? They each have different things inside of it. So the density of something with nothing inside of it, aka air, is less than the density of something with something inside of it, aka a bowling ball. They're the same exact size. You could look at them and say, oh, they're the exact same, right? But all of a sudden this one's heavier than the other because it's more dense. Its density is how much stuff is inside of a thing. Okay? I want you to remember that. How much stuff is inside of a thing. So density can be explained as DMV. Density is mass divided by volume. Okay? Density is mass divided by volume. So mass is the stuff, volume is the thing. It's the space, right? Because volume of a shape is like how much room is inside of a shape. So mass is all the stuff you're shoving into it. Volume is the amount of space you have to shove that stuff in. Okay? Population density. Well, population density, when we say population density, we're talking about the people inside of a state. So population are being shoved into a state, right? Or a country or a continent, right? We're going to stick with state though, okay? Population density, the amount of people inside of a state. So, approximating population density. Vermont has a population of 621,760. Its border can be modeled by the trapezoid 0 with the vertices at 0, 0, 0, 160, 20, 40, 60, 80, 160, and 40, 0. So there's our Vermont, okay? There is our Vermont. Whoops. There's our Vermont. Where each of the unit represents 1 mile, find the approximate population density of Vermont. Round to the nearest tenth. Plot the points and draw the trapezoid. Check. Find the area of the trapezoid. Well, recall our strategy is that you want to draw a box around your shape and then subtract away the area of the objects that you don't need, aka this right triangle. So this is 2 by 1, 2, 3, 4, 5, 6, 7, 8. However, remember, this is 20 and 80, right? Because of, or no, sorry. No, it's not. 40, because we're counting by twos. 20, 40, 60, 80, 100. So this is 40 and this is 160. So find the area of the trapezoid, box minus triangle. So the box is 80 by 160. So 80 by 160 minus 1/2 40 times 160. I'm just going to plug that into a calculator off screen real quick. 80 by 160 is 12,800. This part's review, people. This part's review. This is the same area stuff that we were doing in the last lesson. And when I do 1/2 40 times 160, I get 3,200. And when I do that subtraction, again, I'm just using a calculator off screen here, I get 9,600. Okay? So 9,600 square miles, right? So each unit here represents 1 mile. So 9,600 square miles is the area of Vermont. That's a lot of space. Find the population density. Well, what is the population of Vermont? What is being shoved into the state? 621,000 people, 760, divided by the area of the state, which is 9,600. And when I plug that into my calculator, 621,760 divided by 9,600, I get 64.7. I got a 6 repeating, so that just rounds to 64.8. 64.8. And what is our units here? People per square mile, right? What we're saying is if you chopped Vermont into little tiny squares that are each 1 mile by 1 mile, we could approximate that there are about 64.8 people inside of that block. That's what we're getting. Now, that's not exactly true, right? Because some areas are more dense than others, meaning that a lot of people live in the city, but not so many people live in the rural areas, right? But on average, there are about 64.8 people in each little block. That's what we're getting at here. Let's do it again. Practicing calculating area and practicing this idea of density. So again, maybe before we do this, just thinking about this idea of density. Why does this make sense? What are we doing here? We're wondering how many people are there in a specific area. So you give me an overall population, and you give me the overall area of the state, of the town, of the city, of the country, and you can determine how dense it is. The bigger the number, the more people that are shoved into that area. Think of Tokyo, for example. Tokyo is just people stacked on one another. It's like the tiniest city ever in comparison to other cities in the world, but it's like one of the most populated areas ever. It is extremely dense because all kinds of people are shoved into this small location. There's some rural town that's the exact same size of Tokyo that has like 500 people living in it because it's out in the middle of nowhere. That is not very dense, right? That density would be a much smaller number in that case. So the smaller the number, the less dense. The bigger the number, the more dense. Let's do our lovely state, Nevada. The border of Nevada can be modeled with the polygon 0, 250, 0, 450, 320, 450, 320, 0, and that's it. That makes sense. This little approximation of Nevada. We kind of look like this, right? Our state kind of looks like this. So you can see that I guess I'll draw the box. You can see that if I draw a box around our state of Nevada, that the box is, well, 450 tall and 320 wide. And the triangle that I want to subtract has what dimensions? It's 250 tall and has a base of 320. So our box minus the triangle equals the state. So the box is 450 by 320, and the triangle is 1/2 base times height, and that will equal our state. Again, I'll show you my calculator this time around. Why not? We've got 450 by 320. Oh, that was 4,500. 450 by 320, and I got, it's a big number. I'm not even gonna bother. What is that? 144,000, 3 zeros, and then 1/2 base times height is 40,000. And the number that I just had was 14430 minus the triangle, and I end up with a state size of about 104,000 square miles. That's our proper units for this, or miles squared if you want. And then density is people divided by the square miles. Okay, what did I say up here? I said divided by the state, but the size of the state. So square miles. So people, what's our density here? The population of Nevada. I don't think that's accurate anymore. Divided by, we should update that number to be honest, to make it a little more accurate, 104,000. So what's the density of Nevada? Let me switch over for you. 2723,322 divided by 104,000. 26.1, let's properly round there. The 8 rounds that up to a 2. People per square mile. Now, our state has more people in it than Vermont. But yet Vermont's density is larger. Well, that's because Vermont is smaller. It doesn't matter that there are less people in Vermont. The thing is that it's more dense. You are shoving people into a smaller area. Despite the fact that there are less people, the amount of space for those people is smaller. So therefore, it's more dense. It feels a little more claustrophobic. Think of Nevada. This is a giant state. We got a bunch of desert, pretty or ugly, whatever you think it is, somewhere in the middle. It's a bunch of empty land. It's unlivable, right? It's desert. So there's a bunch of empty space, so the state as a whole is not very dense. Now, Las Vegas is pretty dense. There's a lot of people that live here, but when you look at the state as a whole, we're not really using the space very efficiently, right? There's nothing going on the second you leave town. So Nevada as a whole is considerably less dense than many other states. Hope that made sense to you. Hope that makes sense to you. Thank you for watching. I just realized I didn't have a single question because I get so wrapped up into it. How about this? How about I ask you a question? Okay, here we go. Sorry. Here we go. Give me 2 cities and explain why one is more dense than the other. Or give me 2 states and explain to me why one is more dense than the other. Or something of that nature. Okay? That's what I want you to do. Put that into your own words for me. Alright. Thank you for watching, and I'll see you in class.